Hello students, this is part 4 of the lesson Nature of Matter. In this part, we will be learning about mass, density and pressure. Let's get started with mass. So the activity is measure the weight of different objects using physical balance in your school with your friends and note down the weight. Okay, so they have asked us to note down the weights of different objects. Whenever we go out to a shop to buy vegetables or groceries, most of them will be measured in kgs, correct? So if you want to go out to buy rice, you say I want 5 kgs of rice or 10 kgs of rice or 1 kg of rice and so on. Correct? Similarly, if you want to buy vegetables, you'll say, I need half a kg of tomato. This activity, they have asked us to weigh different objects in your school and mark their weights here. So they have given an example. So there is rice that is of 5 kilograms. Similarly, you can find out the weight of other objects like duster, okay, and etc. Next, we will be learning the definition of mass. So you have to listen to this carefully because this is a very important concept. Okay, so mass is the total quantity of matter cohering together to make an object or a substance. We will break down this definition. So mass is the total quantity of matter. Okay, so matter is another name for materials like we learned. And mass is the total quantity of matter cohering together. Cohering together means that are existing together, sticking to one another. Okay, mass is the total quantity of matter cohering together to make an object or a substance. The mass is measured in terms of weight. The SI unit of mass is kilograms. It means International System of Units. Okay, so SI unit means International System of Units. So SI units are created to make sure that there is a standard all over the world. Okay, so supposing when you grow up, you go out to study somewhere and you want to buy rice, there also you can use a term for mass that is kilograms. Okay, so SI units are created to ensure that there is standard all over the world. So I will repeat this section. Mass is the total quantity of matter cohering together to make an object or a substance. And here they have given us the conversion values of different weights. So 1000 milligrams is 1 gram. So you have to know this. Milli always means if you put 1000 millis together, you get 1 of anything. Okay, so 1000 milligrams is 1 gram. And 1000 grams is 1 kilogram. Kilo is 1000 of anything. Okay, so 1000 grams is 1 kilogram. 100 kilogram is 1 quintal. And 1000 kg is 1 ton. The next activity is you have to ask your elders and learn about the tools used to measure the quantity of objects in olden days and right here. So they have given one example. Rice was measured in pavu. Okay. Similarly, you can find out different quantity tools and write them here. Now it is time for a quiz. The question is, what is the SI unit of mass? If you need time to think, you can pause the video. So the correct answer is kilograms. The SI unit of mass is kilograms. We learned that SI unit is created to make sure that there is standard all over the world and the SI unit of mass is kilograms. Next, we will be talking about density. It is generally said that cotton is light and iron is heavy. Why? Right here. So why do we say that cotton is light and iron is heavy? It is because cotton is easier to lift. Okay, cotton is easier to lift. So we say it's heavy. So we say it's lighter. And iron is more difficult to lift. That is why we can say that it is heavy. When two objects of the same size are measured, one may weigh more and other may weigh less. So similarly, if you take a handful of cotton and try to lift it, and a handful of iron and then try to lift that, we can see that iron is heavier. So why is this the case? Both of them are the same size. Then why is iron heavier than cotton? Let us find out. Generally, we say that the density of less weighing objects is less, and the density of more weighing objects will be more. So they are saying that density of objects which weigh less is lesser, and the density of objects which weigh more is more. So what exactly is this density? Let us find that out. Before that, let us do this activity. Pour a cup of water and a cup of oil into a glass jar. They won't mix together and will be seen separately. So as you can see in this image shown here, on the top you see that it is oil and on the bottom it is water. So why is it the case that oil and water don't mix? I will show you a picture of oil and water that are placed in the same glass. As you can see here, oil is floating on top and the water is in the bottom. They are not mixing together at all. The reason for this is oil molecules and water molecules are of different polar natures. Okay, so you will learn about polarity of molecules in your next classes, higher classes. So the reason why oil and water do not mix is that their molecules do not have any affinity towards each other. Okay, so that is why oil molecules and water molecules do not mix with each other. Now, let us understand the concept of density. What we learnt was cotton was easier to lift than iron because cotton is less dense than iron. Okay, let us understand what exactly density means. So, density is the amount of mass contained in a unit volume. This is the definition of density. Density is the amount of mass that is contained in unit volume. To understand this, I will show you a picture. So you can see here that in the first cube, it's the same size. Both the boxes are of the same size. In the first box, you can see more particles. Imagine you have two boxes and in the first box you place around 5 to 6 balls like it is shown in the first cube here. Okay, and in the next box you can place around 20 balls like it is shown in the second cube here. So which one of them would be heavier to lift? It's the second one because you have placed nearly 20 balls inside it. Okay. Similarly, in any substance, if the number of particles, so the balls that you placed are similar to the particles. If the number of particles is less, it is called of lower density. Okay. Distributions like this, they are called as rarely distributed particles. Rarely means there is distance between them. So if you have placed less particles in an object and there is more distance between the objects, then it is called as less density. Okay, and if there is very dense distribution, so if there is densely distribution of particles, that means there is less distance and there is more number of particles. Density is the amount of mass contained in unit volume. Now, let us go to this activity. Think, which one is heavier, 1 kg of cotton or 1 kg of iron? You have to think a bit for this one because observe here, they have asked 1 kg of cotton and 1 kg of iron. So we know 1 kg is the same. The weight of 1 kg is the same whether it is iron or cotton. So whether you are lifting iron or lifting cotton, 1 kg is same. So they are both the same weight. But the size of cotton would be bigger than the size of iron. If both are of the 1 kg weight, then the size of cotton is greater. That is, you have more cotton than iron. Now let us understand the mass more. Okay. The mass of an object or the weight in grams in 1 cubic meter of its volume is called density. Okay, so we learned that density is the amount of mass contained in unit volume. So density is the amount of mass that is contained in unit volume. Let us write it out here to make us understand better. So density is equal to mass in volume. Okay, so mass contained in unit volume. So they are saying it's the mass of an object in grams. We know that we can measure mass in grams. Okay, so it's the mass of an object in grams present in 1 cubic meter. So 1 cubic meter of volume you take and you see how much mass is there in it. That is called as density of an object. And the SI unit of density is kg per meter cube. So kg per meter cube. Next, let us look into this activity. List objects with higher and lesser density. They have already given us example, that is they have given us oil and water. So oil is of lesser density and water is of greater density. So let us list more objects with less density and high density. So we learned that cotton is of less density and iron is of greater density. So we can give cotton and iron as example for lesser and greater densities. Okay. And one more example for lesser and higher densities can be feather. Feathers of birds is of very light and lesser density. However, bones are higher density. So if you take a bird example, the feathers are of lesser density and bones are of higher density. So you can list out 3 more similar examples. I will leave that out for you. We learned about mass and density. Now let us understand the concept of pressure. The activity is take a tumbler containing water. A tumbler is nothing but a container. So you can take a container of water and place a blade horizontally. Horizontally is like this. Okay, like they have placed here, and vertically is like this. Okay, so take a tumbler and place a blade horizontally and see what happens. So you can see that it is floating. And place the same blade perpendicular to the surface of water. So here what they have done, if this is the water surface, they have placed the blade perpendicular to the water surface. Then see what happens. I have drawn 2 diagrams here to show you what happens when the blade is placed horizontally and vertically. If you can see here in the first diagram, when the blade is placed horizontally, the entire surface of the blade, okay, so the entire surface of the blade, all of this region, it is pushed by the water. So all of that region is being pushed by the water. But when the blade is placed vertically, there's only a small area which is being pushed by the water. Okay, so when the blade is placed horizontally, there's a large surface which is being pushed by the water from below. When the blade is placed vertically, only a small region, that is only the thin part of the blade, is being pushed by the water. This is why even though both of the blade are of the same mass, it's the same blade, so the weight would be the same. When you place it horizontally, it floats. When you place it vertically, that is perpendicular to the surface of the water, it will sink. Even though the mass of the blade is the same, it floats in the former case and sinks in the latter case. Okay, so former means the first case, latter means the second case. Okay, when the blade is placed horizontally, its mass is distributed over the wide area. Therefore, mass per unit area is less. So, when the blade is placed like this, its mass is distributed over a wide area, and the water pressure from below is enough to push it up from down. That is why the mass per unit area is less and hence it floats. Okay, so the mass per unit area is less and hence it floats. When the blade is kept perpendicular to the water surface, it sinks since the mass distributed over a smaller area. So it sinks because the mass is distributed over a smaller area. Therefore, the consequence depends upon mass per unit area. Consequence is result. Does it float or does it sink? So that depends upon the mass per unit area. This mass per unit area is called as the pressure. Okay, pressure is exerted on a unit area. Let us understand this more using another experiment. Immerse a stone gently into a glass beaker containing water. So immerse a stone gently into a glass beaker containing water. What happens? Right here, what you have noticed. So the stone sinks. Then immerse a wooden plank into another beaker containing water. Right here, what you have noticed. So the wooden plank, it floats on water. So the wooden plank, it floats on water. When an object is immersed in water, it extends a downward force on the water. So what they're saying, when an object like this is immersed in water, it exerts a downward force. Okay. And the water in turn exerts an upward force. So as you can see here, water is also pushing it up. Okay. So the water in turn exerts a upward force. If the upward force exerted on the object is more than the downward force, so if this upward force that is exerted by the object, so if this upward force that is exerted, sorry, not by the object, by water is more than this downward force, so the water is exerting an upward force like this and the object is exerting a downward force like this. So the object will float, that is, it will not come down if the upward thrust is more than the downward force. This upward force that is exerted by the water is called as buoyancy. Okay, so this upward thrust is called as buoyancy. The next part, we have to write any four objects that float on water. One example they have only given, it is wooden plank. So wooden plank, they float on water. So leaf, if you can see, leaves also they float on water. Next, what else floats on water? You need to think of two more examples and write here. I will leave this one to you. In the next activity, we have to fill water in a glass jar as shown in the picture. Then put marble. So they are putting marble, coin, dried leaf. Okay, so they are putting marble, coin, dried leaf, wooden plank and straw in the jar. Find the objects around you and put them in the jar. Be careful because water may cause damage to them. Ask your friends to tell what happens to each object when you put it by observing it. So, you can take these objects and try to see if they float or they sink. Some objects float in the water and some objects sink. Okay, some they float in the water and some of them sink. The next part of the activity is you have to list down the objects that float in the water and objects that sink. So, Objects that float in the water in the examples they have given will include the dried leaf, wooden plank, straw, etc. Okay? And the objects that sink will include the coin and marble. So you can add to this list if you have experimented with any other objects also. Next, a raft does not sink in water. Why? To understand why the raft does not sink in water, I will show you a picture of a raft. So as you can see here, the raft is made up of wood or bamboo. And we just learned that wooden planks float on water. So wood is a floating substance, and also they can see here that the raft is placed in such a manner that its mass is spread over a large surface area. Okay, so the pressure or the force per unit area, that is of the water upwards, would balance the weight of the raft, that is downwards. That is why rafts, they float on water. The next question is, what objects are used to immerse the wooden plank in water? So I have understood this question like, if you want to immerse a wooden plank in water, how can you do it? You can do it by placing heavy weight on top of the wooden plank. So if you place heavy weight on top of the wooden plank, then the wooden plank will be immersed in water. Next, we will be learning about solubility. Okay, so we have learnt about mass, weight, density, pressure. Now we will learn about solubility. To do this, fill water in 2 glass jars as shown in the picture. Now pour sugar into one and charcoal powder into another and stir. So they have poured sugar into this one and charcoal powder into this one. Okay, and now they are stirring. What happens? Did the sugar and charcoal powder dissolve in water? Write your observation here. Okay, so we will be able to see that sugar dissolves in water, but charcoal does not dissolve. Okay, so only sugar dissolves in water, whereas charcoal powder does not. Why is that? Some objects dissolve in water. This is called as solubility. Okay, the property by which objects dissolve in water is called as solubility. Some objects dissolve and some objects do not dissolve in water. Next part of the activity, we have to decide which of these are soluble in water and which of these are not. Okay, so if it dissolves in water, you call it as soluble in water. If it does not dissolve in water, you call it as insoluble objects in water. Okay, so I will just give you examples of this. You should do the remaining ones. So the first one, that is salt, we know that salt dissolves in water. So we have to place salt in the first part, that is soluble objects. Okay, and sand does not dissolve in water. If you have went to the ocean, you will see sand and water in the same place, correct? Even when the ocean comes onto the sand does not dissolve. So sand is insoluble. You have to classify the remaining and put them in the appropriate column. I will leave that to you. Activity is, you have to give examples for floating and sinking objects, and they have given space here on the boat and on the beaker. You have to write them here. This is also an easy experiment. I will just give you one example for each. For a floating object, you can say raft, right? And for a sinking object, you can say stone. You can add the rest of the examples. I will go to the next activity. The next activity is similar. You have to write soluble and insoluble objects. So in the first one, the clear glass beaker, you have to give examples for soluble objects. I will give sugar as an example. In the next one, you have to give examples for insoluble objects which are undissolved here. I will give pieces of glass. Okay, so you can give the rest of the examples here. Then, based on the arrangement of particles, the matter is classified into three physical states, namely solids, liquids, and gases. Apart from this, matter can be classified as elements, compounds, and mixtures. So, you will learn about this classification in the next lesson.
I will be revising the important concepts that we have learned in this lesson. Firstly, we learned that matter is scientifically materials are called as matter. Next, we learned that the characteristics of matter are it has mass and it occupies space. Okay, and then we learned that the three states of matter are solids, liquids, and gases. Then mass. Mass is the total quantity of matter in any substance. Then density. Density is the amount of mass contained in unit volume of a substance. Okay, so the amount of mass contained in unit volume of a substance is its density. Pressure is the force per unit area. So pressure is the force per unit area. Next, buoyancy is the upward force that is exerted by water. So these are the important definitions that we learned. This is the end of Unit 4 of the lesson Nature of Matter. This completes the lesson Nature of Matter.